Alright, hello everyone. Another video for you guys. Going to continue talking about proxy servers. Uh, I just wanted you to know before, if you were watching the last video, we're going to talk about encrypted traffic entering the network. It must first be decrypted for a load balancer to direct requests to different servers. A reverse proxy can be the point at which this traffic is decrypted. Sorry, it's got an E in a bit, but access to forward proxy servers is usually configured in the operating system. However, a transport proxy does not require any configuration on the user's computer. It is often used for content filtering in schools and libraries. Although forward proxy servers can have some disadvantages, such as added expense and the fact that caches may not always be current, they have several advantages. One of the advantages is increased speed. Because forward proxy servers can cache material, a request can be served from the cache instead of retrieving the web page through the internet. Reduced costs is another benefit or advantage. A proxy server can reduce the amount of bandwidth usage because of the cache. Another advantage is improved management. A forward proxy server can block specific web pages and entire websites. Some proxy servers can block entire categories of websites, such as entertainment, pornography, or gaming sites. Another advantage is strong security. Acting as an intermediary, a proxy server can protect clients from malware by intercepting it before it reaches the client. In addition, a proxy server can hide the IP address of client systems inside the secure network. Only the proxy server's IP address is used on the open internet. So I know you guys probably been looking at this over here. I described it in other videos, but this is VM Workstation. It's a software for virtualization, and I am using CentOS here. I have it open. I will be doing some demonstrations with this as well. So right now we're gonna just continue to talk about network security hardware. So although standard networking devices can provide a degree of security, hardware devices that are specifically designed for security can give a much higher level of protection. These devices include firewalls, virtual private network concentrators, mail gateways, network intrusion detection and prevention systems, security and information event management devices, and other devices. So let's talk about firewalls. Both national and local building codes require commercial buildings, apartments, and other similar structures to have a firewall. So in building constructions, a firewall is usually a brick, concrete, or masonry unit positioned vertically through all stories of the building. Its purpose is to contain a fire and prevent it from spreading. A computer firewall serves as a similar purpose. It is designed to limit the spread of malware. There are two types of firewalls. There's a software firewall, and then there's a hardware firewall. A software firewall runs as a program or service on the device, such as a computer or router. A hardware firewall are specialized separate devices that inspect traffic. So there's a big difference. Some people are like, oh, I do have a firewall on my computer, and it's a software firewall. The majority of people have software firewalls. The minority of people have hardware firewalls. They do different jobs. So understand that. That's important to understand. If you don't understand that, contact me. If that just confused you right there, contact me. I will help you. So hardware firewalls are specialized separate devices that inspect traffic. Because they are specialized devices, hardware firewalls tend to be more expensive and more difficult to configure and manage. That's where I come in. I'll help you configure and manage that. I can do that for you. You look at that box and you just don't know what to do with it. You call me and we'll get it done. An enterprise hardware firewall is shown in some images. I'm gonna show you a Jupiter firewall on a later video. It's an enterprise hardware firewall, so you can see what they look like. If you don't, if if you do have access to the internet, most you're probably watching this through the internet. Just look them up, enterprise hardware firewall, so you can see what they look like and see what we're talking about. So I want you to note that a disadvantage of a software firewall is that a malware infection on the device on which it is running, such as a computer, could also compromise the software firewall. So that's a disadvantage of a software firewall, is that if your computer gets infected, uh, that software firewall can also be compromised. So because a hardware firewall does not depend on an underlying device, this is not an issue with a hardware firewall. That's that's the reason why you want a hardware firewall and a software firewall. I'm not telling you to not use any software firewalls. I'm telling you to use hardware firewalls, and I'm telling you software firewalls to help improve your security in your network infrastructure. All right. Software firewalls running on a device provide protection to that device only. One common example is a software firewall that runs as a program on a local computer to block or filter traffic coming into and out of the computer. All modern operating systems include software firewall, usually called a host-based firewall or a personal firewall. The settings for the Windows personal firewall are located inside of the program. If you do not know how to get to that, just let me know. If an application or program running on a computer needs to communicate with another computer on the local area network or internet server, the user can create an opening port in that personal firewall for the application or program only, approving the application to transmit, called unblocking basically. This is more secure than permanently opening a port in the firewall. When a permanent firewall opening is made, it always remains open and is then susceptible to attackers. But when a port is unblocked by a personal firewall, it is open only when the application requires it. And so, understand the difference there. And if you don't understand the difference, just contact me. We talk about it. Please contact me. That's the whole point of the majority of the videos. Contact me, because I know a lot of this is advanced and people are like, what? What are you talking about? I can help you understand. I'll connect to your systems remotely, and I'll be able to show you while you're actually looking at it. So please use me. Personal firewalls can limit the spread of malware into the computer, as well as preventing a user's infected computer from attacking other computers. For many personal firewalls, inbound connections, data coming in from another source, are always blocked unless there are specific firewall rules that allow them in. This principle of being always blocked by default is called implicit deny. That is, an action is always denied unless it is definitely and explicitly allowed. Outbound connections are always allowed unless there is a rule that blocks them and the outbound rules are turned on. A firewall that protects an entire network is typically a separate hardware device. These hardware firewalls are usually located outside the network security perimeter as the first line of defense. Different firewalls provide different functions, which leads to different levels of protection. These can be divided into network layer based firewall and application layer based firewalls. So let's talk more about network based firewalls. A network based firewall functions at the network layer 3. Its job is to screen packets based on specific criteria, making it essentially a packet filter. Note that network-based firewalls are not the same as network firewalls that protect entire networks, like discussed in the previous section I was talking about. A network-based firewall is one that operates at the OSI network layer 3. Packets can be filtered by a firewall in one of two ways. Stateless packet filtering looks at the incoming packets and permits or denies it based on the conditions that have been set by the administrator. Stateful packet filtering keeps record of the state of connection between an internal computer and an external device, and then makes decisions based on the connection as well as the conditions. An example would be a stateless packet filter firewall might allow a packet to pass through because it is intended for a specific computer on the network. However, a stateful packet filter would not let a packet pass if that internal network computer did not first request the information from the external server. Okay, so a firewall can take different actions when it receives a packet. Allow, drop, reject, or ask. Much like routers, some firewalls use criteria for accepting or rejecting a packet based on an access control list. Sometimes called rule-based firewalls, they use a set of individual instructions to control actions. These firewall access control list rules are a single line of textual information containing such information, like a source address. The source address is located of the origination of the packet, where the packet is from. Addresses generally can be indicated by a specific IP address or a range of IP address and IP mask, the MAC address or host name, the destination address. This is we're going to talk about destination address. The source address, the destination address, the source port, the destination port. These all have their individual. These are all individual subjects that have a good amount of information about them. So I'm briefly going to give you an intro to all of them and tell you a bit about them. But please contact me if you need more, or please do your own research, because these topics is important to understand the entire idea of what we're talking about. I'm giving you bits, and you have to understand that. So please do contact me or do your research about it, and if you have any questions, we'll figure this out together. So where I'm talking about destination address right now, this is an address the connection is attempting to reach, where the packet is going to. These addresses can be indicated in the same way as the source address. A source port, the source port is a TCP/IP port number being used to send packets of data through. Options for setting the source port often include a specific port number, a range of numbers, or any port. A destination port. This setting gives the port on the remote computer or device that the packets will use. A protocol. The protocol defines a protocol such as TCP, UDP, ICMP, IP that is being used when sending or receiving packets. Direction. The direction shows the direction of traffic for the data packet, in, out, or both. Action. The action setting indicates what the firewall should do when the conditions of the rule are met. These options may be the following: allow, drop, reject, or ask. Yeah, I know that's a lot of information, and I know when I was getting introduced to all of this that you're probably like, what is that? What does that mean? What does source port mean? What does TCP mean? What does IP mean? What does ICMP mean? Why is any of this information even relevant? Like what is this used for? And just please understand that all of those acronyms, all these protocols that we're talking about, all these settings they all have a purpose. They're all building blocks to something, a bigger picture. So just stay with me and stay disciplined, and you'll understand the bigger picture as we keep on going through this. This is about information security. This is about network engineering. So just stay with me, and slowly but surely you'll get the overall idea of what's going on. So each firewall access control list rule is a separate instruction process and sequence that tells the firewall precisely what action to take with each packet that comes through it. The rules are stored together in one or more text files that are read when the firewall starts. Rule-based systems are static in nature and cannot do anything other than what they have been expressively configured to do. Although this makes them more straightforward to configure, they are less flexible and cannot adapt to changing circumstances. Note that firewall rules are essential, and using if and then construction. If these rules conditions are met, then the action occurs. So that is what if and then construction is. If these rule conditions are met, then the action occurs. So application-based firewalls. Okay, a more intelligent firewall is an application-based firewall operating at the application layer 7. Application-based firewalls operate at a higher level by identifying the applications that send packets through the firewall and then make decisions about the application instead of filtering the packets based on granular rule settings like the destination port or protocol. Applications can be identified by application-based firewalls through predefined application signatures, header inspections, or payload analysis. In addition, application-based firewalls can learn new applications by watching how they behave and even create a baseline of normal behavior so that an alert can be raised if the application deviates from the baseline. An example of how an application-based firewall and a network-based access control firewall compare can be seen in how they filter specific web applications. An organization might frown upon employees using a network during normal business hours to stream online movies, but still need to provide employees with an access to an online sales application. Setting an access control list rule in a network-based firewall to prevent streaming video would also stop access to the online sales application. An application-based firewall, though, in contrast, could distinguish between these two applications and allow access to the sales application while blocking the streaming video, the social networking, and gaming things that can be happening in the network. Or it could also allow these applications but limit the bandwidth consumption to give priority to the business applications that are being used at that corporation. A special type of application-based firewall is a web application firewall that looks at the applications using HTTP. A web application firewall, which can be a separate hardware appliance or a software plugin, can block specific websites or attacks that attempt to exploit known vulnerabilities in a specific client software, and can even block cross-site scripting and SQL injection attacks. All right. I'm going to stop right there. I know this video went longer than all of the other videos. We're talking about a lot of firewalls, so I didn't want to, stop talking about firewalls. Firewalls are a very important part of security. So I hope you really enjoyed this information about firewalls. If you have any questions, please contact me. Please like, subscribe, donate, share, and I'll be bringing more videos to you soon. Thank you for watching.